So we know if we have just x being squared or some quantity being squared, you could square root both sides. And thankfully, since this is a positive number, we don't have to worry about complex numbers. We don't have to worry about i's. Instead, we do have to worry about it being a positive or a negative, and the square root of 144 is just 12. Cool. Now, for most of our other quadratics, when I had numbers that weren't 0 on one side and then other stuff on the other side, what were you told to do? Set it equal to 0, Mr. DeGeese. This is completely correct. Pay attention, Mr. Cherba. Why do we want to set things equal to 0? Because it's actually advantageous. Because if I can factor, a factored form equals 0, that's good. Because that's how we can see, and don't write this down, if I have x plus 2 times x plus 3 equals 0, that's easy to see -2 and -3, right? But what if this was 10? Are the answers still -3 and -2? No, it's not. So this is not helpful. 0 is helpful. However, we actually aren't going to subtract 100 from both sides. Not now. Because watch what happens if I do factor this left side. I notice something. Let's think. What are the two numbers that add to get -16 and multiply to get 64? 8 and 8, very good, Mr. Charles. Which means this turns into x minus 8 times x minus 8 equals 100. Now again, is our answer 8? No, because it'd be 0 equals 100. That's not correct. So this is still not helpful. But how can you write x minus 8 times x minus 8? Oh, it's awesome. This is x minus 8 squared. Now, what can I do?
You do the square root.
I can square root. Now I have some stuff being squared. I don't have x squareds and x's. Because this is a perfect square, you can square root. You get x minus 8 equals plus or minus 10. I don't like to, maybe we'll do it here. That means my answers are 8 plus 10 and 8 minus 10, right? Because I add 8 to both sides. That's 18 and -2. Yes. Notice how I did not get positive 18 and -18. I'm adding to both sides. I'm adding to positive 10 and adding to -10. I get 18, -2. All of a sudden, man, I could use square roots, even though I started with x squareds and x's, because it's a perfect square. So, do the same process for this. This is a perfect square. What are the two numbers that add to get 30 and multiply to get 225? 15 and 15 is a good guess, and you are correct. So please rewrite this as x plus 15 times x plus 15, or even skip that step and write this as x plus 15 squared equals 121, and then we can square root both sides and solve. Go ahead. I'll show you all the steps here. I got x plus 15 times x plus 15 equals 121. I could write this as x plus 15 squared, as Mr. Charles told us to do. You then have stuff being squared. We talked about how you can square root to solve this. Everything is working out very nicely so far. X plus 15 equals plus or minus 11. That's positive 11 and negative 11. Now be careful. Should I add 15 to both sides? No. What should I do, Miss Abernathy?
You should
subtract 15 or add negative 15 from both sides. Now, I'll just do it all in one step. Negative 15 plus 11, negative 4. Negative 15 minus 11, or negative 15 plus negative 11, negative 26. Crazy, but those are my two answers that solve that equation. Okay, you guys try the next one. Go ahead, do it. Please. What? All we're doing is looking for two numbers that add to get negative 6.
What do you do? 2x.
There's no 2x.
No, the x.
I made this look like this. That then looks like this. The two numbers that add to get 30 and multiply to get 225 are 15 and 15. So I can write x squared plus 30, x plus 225 is x plus 15 times x plus 50.
So, for this one to get negative 6, I would say negative 3 and positive 3.
Nope, because that would add to give you 0. I want negative 3 plus negative 3 to give me negative 6. And then when they multiply, they get positive 9. So minus 3 squared. The two numbers are negative 3 and negative 3. X minus 3 equals 1. Sure, answer's not 3, but we write this as x minus 3 squared equals 1. Square root, I have x minus 3 equals plus or minus the square root of 1, which is just 1. Schumacher, what do we do with this x minus 3? How do I get rid of that? Add 3 in this case. I add 3 to get positive 1 plus 3, which is 4, and negative 1 plus 3, which is 2. Okay? Notice, these are easy ways to get answers. If I ended up subtracting the negative 121, we still would be able to factor, but it's actually very tough to find like positive 4 and 26 are the two numbers that add to get 225, add to get 30 and multiply to get 225 minus 121. So this is a different way. Also, we are about to learn this technique, which is called completing the square. It is a great technique that will allow you to solve any quadratic with x squareds and x's by square rooting. I told you you couldn't. X squared plus 5x plus 6 equals 0. We don't use square roots, we factor, but actually we'll be able to use square roots. Okay? And here's the key. The key is the fact that we have this quantity being squared, a perfect square, a perfect square. Well, what we are going to want to do is create a perfect square. So, what could this number C have to be if this was x plus 7 squared? Think about this. Everybody think about this. This is important. Everybody focus too. An introduction on this stuff. What number would C have to be so it's x plus 7 squared? Mr. Asmussen, what do you think?
Is it 196?
It is not 196. It is 49. How is it 49? Now, I kind of led you there. I gave you a 7. Why didn't I give you x plus 14 squared? Because if we think about x plus 14 squared, it'd be x squared plus 28 plus, what was 14 squared? 196. So this turns into this. But I didn't use 14, I used 7. Why did I use 7? Because I know when I square x plus 7, it's x plus 7 times x plus 7. These two numbers would add to get this 14. And then multiply to get the 49, right? So what I actually did is I took this middle number, I divided it by 2. And I knew, okay, I needed to have a 7. And then how did we get the 49? We squared that 7. Okay? Let's look at this one. This is not a good one. Change that to a 10. Actually, no. We're going to keep it like this. Okay? Not nice, but it'll work. I know 9 divided by 2 is 4.5. If I want this to turn into this, what does C have to be? .5 squared. $20.25. Okay, this is tricky for you guys to figure out. What we need is this middle term to be divided by 2 because I know when I have x plus 7 times x plus 7, I got the 7 plus the 7 is 14. So if I take 14 divided by 2, I know it's got to be x plus 7. But then I'd take that 7 and square it because when I distribute everything, my last thing would be 7 times 7, which is 49. Okay? So here's what we're going to do. Skip these steps, so I'm going to just tell you those steps while we do this first one. Let's do the second one, actually. Okay? What we are going to do first, to solve this using square roots, because you notice you can't factor it, right? There's no two numbers that multiply to get 1 and add to get -6. The first thing you're going to do is get rid of your numbers. Subtract 1. You're left with x squared minus 6x equals -1. Now, I want to write this as x minus 3 squared. But before I can do that, I need to add an amount right here, and it needs to be added to the other side so that this is a perfect square. To find that number, what is the number?
Oh wait, or it needs that 0. You divide the middle number by 2.
Take the middle number divided by 2 and square it. -6 divided by 2, -3 squared, 9. We are going to add 9 so that this is x minus 3 squared. But I can't just add 9 to one side of an equation. Why? It would unbalance the equation. To keep things equal, whatever you have to do, you do it to both sides of the equation. So you're going to add 9 to both sides. And all of a sudden, this turns into x minus 3 squared equals 8. We are now able to square root both sides. X minus 3 equals plus or minus root 8. Now we know the square root of 8 is the square root of 4 times the square root of 2. That's 2 root 2. Add 3. I'll get 3 plus 2 root 2 and 3 minus 2 root 2. Okay, I'm going to walk you through it, and you're going to do every step along the way. Okay, we're going to do number 8. We'll go back to 5 and 7. They're actually easier. Okay, ready? Everybody's going to do it. I'm not going to show you. You're not going to just copy it down. You're going to just do what I tell you to do, and you're going to do it correctly. First thing is to get rid of all of the numbers that are next to the x squareds and the x's. So please identify what you need to get rid of and remove it from that one side by adding the opposite. We're doing number 8 right now. Remove all of the numbers that are bothering the x squareds and the x's, please. Everybody do that. Ms. Pierce, what are you doing? Move the 4. Good. So, Mr. Quinn, please add the 4 to both sides. Now, you have x squared plus 10x equals 3. We are going to add a number to both sides of the equation so that the left side is a perfect square. To figure out that number, I take this 10, I divide it by 2, and I square it. So, stay with me. What is the number that I'm going to add to both sides so that I have a perfect square on the left side? 25. Everybody add 25 to both sides. Because if I add 25 to both sides, the left side is now a perfect square. Follow along with me, please.
I think I'm...
You're really close. It's not minus 5 times minus, it's positive 5. No, just add x squared plus 10x plus 25, and then 3 plus 25.
Why are you adding the 25 again?
Because it would create a perfect square on that left side. And we talked about, so the question was, why are we adding? If we have a perfect square, I can solve using a square root. So I want to create a perfect square. This is why we call it completing the square. We are taking this and we are turning it into a perfect square by adding 25. See that? This is where we should have. Are we here, Mr. Cherba? The reason why we did this is because this is x plus 5 times x plus 5. This is x plus 5 squared. The 5 comes from this 10 divided by 2. The 25 we needed because x plus 5 squared is x squared plus 10x plus 25. Square root both sides. Square root of 28 is root 7 times root 4, which is 2 root 7. Then subtract 5. Awesome. And you have a difficult looking answer, but a correct answer. Yes, Ms. Abernathy. Yes, did you write down the correct answer here? It's root 4. Root 28 is root 4 times root 7.
Okay.
It's not what adds, it's what multiplies.
Okay.
So please change that. Two root 7 is the same as the square root of 28. Stay with me, Mr. Quinn. Feel like you don't want, well, we don't do math, we don't learn math by looking at it. We will learn math by doing it. We will finish by subtracting 5 from both sides, which is adding negative 5. Negative 5 plus 2 root 7, and negative 5 minus 2 root 7. Okay. Try. Oh gosh, that one's not fun. Let's do this one. This one's better. I will walk you through it, but I want you to do it with me, please. What's the first step? Who can tell me? Yes, remove the stuff that's bothering the x squareds and the x's. Add the 1. What's the next step? Yep. We added the 1. Yes. Take the term with the x's, divide it by 2, and then square it. Well, 2 divided by 2 is 1, 1 squared is 1. So we start out with x squared plus 2x equals 1. This divided by 2 squared is 1. So I will add 1 to both sides, giving me x squared plus 2x plus 1 equals 2. You can then rewrite x squared plus 2x plus 1 as a perfect square. This is x plus 1 times x plus 1, which is x plus 1 squared. You can square root, and you can subtract 1. Okay, skip this one. Let's go to the next page. If you don't just have x squared, you have 3x squared, get rid of the leading coefficient. Get rid of a by dividing first. I could divide everything by 3 first. Gives me x squared plus 8x plus 5 equals 0. We're on the next page. A is like ax squared plus bx plus c. So like the general form of a quadratic. Ax squared plus bx plus c. Divide by a. Okay. Mr. Quinn, now that I have x squared plus 8x plus 5, subtract 5. Miss Arbogast, what do I do now?
You divide the 8 and then
Divide the 8 by what?
2.
Okay, and I get 4. And what do I do with that 4?
You square it.
And what do I do with that 16?
You add it to the side.
Add 16 to both sides. This is how I get a perfect square. Because I know x plus 4 squared is x squared plus 8x plus 16. Why am I taking 8 divided by 2 and squaring it? That's how I can easily figure out this number. I know I'm going to have x plus 4 because I'm going to have x plus 4 times x plus 4. I'll have that 4 plus 4 to give me 8. That is why I divide 8 by 2. This turns into x plus 4 squared. That equals 11.
What happened to 8? Where'd that go?
What happened to this 8?
Yeah.
What's x plus 4 squared? Oh, wait, never mind. It's x squared plus 8x plus 16. Mr. Black, what do I do next? I'm right here. X plus 4 squared equals 11.
Oh, then you would square root the x or?
Square root both sides. The square root of 11 cannot be simplified. Don't forget your plus or minus. Finish off by subtracting 4. Okay, number 10. Everybody, divide by 2. By everything by 2. Get rid of that 2. You have to divide the right side too, but 0 divided by 2 is just 0. Okay, finish it off. We divided all of these by 2. I'm over here now. More on this one. Go ahead, do every step. Okay, but before you make this x minus 4 squared, you need to add something to both sides to enable you to write it as x minus 4 squared. So that number 2 needs to change. X squared, not 2x, x squared minus 16x. And you forgot to divide everything by 2. So 2x divided by 2 is x squared. That's 8x. Good. We got rid of the 2. X squared minus 8x plus something. Sure. Why did I add 16? Because x squared plus 8x is not a perfect square, but x squared plus 8x plus 16 is. I know to add this 16 because I know I need an x plus 4 being squared. I know it's x plus 4 because I have x squared, 4x, another 4x, and 16. So I ended up just taking this number, dividing it by 2, and since it's x plus 4 squared is 16.
You can't do that with that.
You're going to do the same thing. You're going to add 16 to this one as well.
But that's a negative. It says you can't carry a negative. If it's a negative 4. If you divide it by 2.
What's negative 4 times negative 4?
16.
So you can. You're going to have to try and embrace this, or you'll be lost for forever. We get rid of the 2. Mr. Quinn, do we know what x plus 3 squared can be simplified to look at? Is it x squared plus 9? I'm just making this up here. Because if we understand this, we should understand why we need what we need. You don't know what x plus 3 squared is. It's okay if you don't. It's x plus 3 times x plus 3, which is x squared plus 3x plus 3x plus 9. That's x squared plus 6x plus 9. what we are doing, Mr. Quinn, is taking this, turning it into that. But before we do that, it's going to be a situation where we don't have that number. But we do realize, oh, if we want to take this and turn it into this, I need to add 9 so that it is x plus 3 squared. I feel like you're just deciding to space out instead of just embracing it and saying, okay, I can figure this out. X squared minus 8x plus 16 equals 18. Why did I add 16? Because negative 8 divided by 2 is negative 4. Negative 4 squared is 16. And when I add 16, this is a perfect square. But it's not x plus 4 like the other one. It's x minus 4.
Is that always going to be a positive number?
It will always be a positive number, Mr. Bernenberg. Great observation. Why do you know it's always going to be a positive number? Because b divided by 2, whether it's positive or negative, will be squared. And when you square a number, when you square a number, it's always going to be a positive, which is why, yes, this number will always be a positive. Okay, now we square root 18. It's 3 root 2, because it's root 9 root 2. So x minus 4 equals plus or minus 3 root 2. We will add the 4. X equals 4 plus or minus 3 root 2. You know what's great about this? We can actually find the vertex of a parabola using this technique. You guys remember vertex form? Remember that? A times x minus h squared plus k. Does that look familiar to any of you? Remember the vertex is at hk. We can write an equation in vertex form by completing the square. Okay? Watch. Get rid of the 3. But keep the y. We just did this one. If I have x squared minus 8x, negative 8 divided by 2, negative 4 squared, 16, right? Add 16 to both sides. Y plus 13 equals x squared minus 8x plus 16. Now, we're not solving here, so watch. I know the right side's going to look like x minus 4 squared. But watch my final step. I'm going to move that 13 back over. And I find my vertex is at 4, negative 13.
I have a question.
Yep.
If you've already added plus 16 to the other side, why do you keep it on the right side?
So you're saying, why do I do it on both sides?
Well, no, but like, why would you do it on both sides, but you're keeping it on the right side? Oh, wait.
Well, because I can't add the 16 with anything else here. But here on the left side, I can add it to the negative 3. So if I didn't have any numbers here, I would write it y plus 16. But since I do have a numbers, I'm combining the two numbers. Okay? Now, graph this equation for me. This is the vertex at 4, negative 13. This divided by 2 squared. Graph x squared minus 8x plus 3 is the vertex at 4, negative 13. No? If not, then I made a mistake. Go over trace. Why don't you just press trace and do 4? Yeah. Do you see the 0.4 negative 13? You could also do the minimum. Remember trace? Just trace, trace, 4, enter. Okay? Okay, ready? Add the 1 to both sides. Get rid of the 1, but make it y plus 1. Number 12, here we go. Add the 1 to both sides. Make it y plus 1 on the left side. Find the number that you should add to both sides to make the right side a perfect square. Please do this. We have to try this. If we just keep copying down, we're never going to be able to do it ourselves. Add the 1 to both sides, please. Find the number that you add to both sides to make the right side a perfect square. You are then able to rewrite the right side as a x plus something square. And you can move that 10 back over. You have x squared plus 6x. Find the number to add so that it's x squared plus 6x plus something that makes that a perfect square. Take, if you don't know, take that middle term, that b term, that 6, divide it by 2 and square it. That's beautiful. What's the number that we add to both sides, Ms. Villamore? Right here. Which number do I add to both sides? 9. 6 divided by 2 squared. Add 9. You get y plus 10 equals x squared plus 6x plus 9. It's always going to be b divided by 2 squared because this is x plus 3 squared. X plus 3 times x plus 3. Those are the two numbers that add to get 6 and multiply to get 9. We finish off by subtracting 10. I get y equals x plus 3 squared minus 10. I can see my vertex is going to be at negative 3, negative 10. If you graph that, you would see the same thing. Remember, it's x minus h. It's the whole transformations. If I have inside parentheses a plus, I'm shifting y equals x squared to the left, not to the right. Okay. These also work with imaginary numbers, which is why it's such a powerful tool, this concept of completing the square. Let's look at number 1 on this part. So flip the page over, please. What is great is that it's a very consistent process. It's not hard. If you're just going to practice it, you're going to get it. Get rid of the 5. figure out a number to add to both sides so that we get a perfect square. You guys don't have this? Okay. This actually isn't a complex solution, so it's a bad example, but whatever, it's the same thing. Mr. Quinn, which number am I going to add to both sides? We know it's always going to be positive because any number squared is going to be positive. I will remind you, the key is this b over 2 squared. What is it? Yep. Mr. Quinn, what's 18 divided by 2 squared, please? Yes, because we remember that we will be fine when completing a square. We get x squared minus 18x plus 81 equals 76. The two numbers that add to get negative 18 and multiply to get 81 are negative 9 and negative 9. This is x minus 9 squared equals 76. Let's not bother simplifying this root 76. We'd get x minus 9 equals plus or minus root 76. We'll add 9. X equals 9 plus or minus root 76. Okay, not a great example, but look at number 2. Step 1, get rid of the numbers. Subtract 11. I get x squared plus 6x equals negative 11. Mr. Charles, what number do I add to both sides so I can complete the square on the left side? Thank you. 9. Perfect. B divided by 2 squared. Add 9, add 9. The left side turns into x plus 3 squared because 3 plus 3 is 6 and 3 times 3 is 9. This equals negative 2. Uh-oh. Square root both sides. This turns into root 2i. But we're not afraid of that. We know that the square root of negative 2 is just root 2i. This turns into negative 3 plus or minus root 2i. Number 3, please subtract 20 from both sides. Mr. Sripata, what is the number that I add to both sides so that I complete the square on the left side? What is the number I add to both sides after I've subtracted the 20? 4 is correct. B divided by 2 squared. We got this, Mr. Quinn? B divided by 2 squared. 2 squared, 4. Add 4. This turns into negative 16. This is a perfect square. The two numbers that add to get 4 and multiply to get 4 are 2 and 2. This is x plus 2 times x plus 2. This is x plus 2 squared. We square root both sides. We have plus or minus 4i. How do I know that's 4i? The square roots of negative numbers have to involve I. Square root of 16 is 4. Square root of negative 1 is I. My answers are negative 2 plus or minus 4i. One more. and then I'll give you the rest of the time to relax. Maybe we'll do this one. Let's do it, everybody. If you do number 4 correct, I will feel happy about myself. Go. I know, I'm literally just looking at you right now. Here we go. Please do it.
I know how to do that one part.
If you know how to do that one part, you're ready for everything. What's your first step, Mr. Charles? Okay. You already know more than you let on to know. Not 4.
2.
8 divided by 2 squared. Okay? 8 divided by 2 squared. Now, add 16, it's not x plus 16 squared.
Why?
Because x plus 16 squared is x squared plus 32x plus whatever 16 squared is.
Can you like sum that up? I don't know what that means.
If you add 16, and you got that, right?
Because it's from this, right?
Okay, now, what is equal to this? X plus 16 squared equals x squared minus 8x plus 16. What two numbers add to get negative 8 and multiply to get 16? 4. Negative 4 and negative 4. So,
That goes in x plus.
yes.
Okay.
We're going to have a quiz on this next class, obviously, and we will not, we literally spent an hour doing this, and you could not get one. We spent an hour doing this. How can you not understand after an hour of the same thing over and 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 over again? There's some mental breakdown somewhere.